Hello everyone, in today's lesson we are going to see how to check if two shapes are similar and also how to check whether they are congruent. Similar shapes are shapes that have a scale factor. For example, one is an enlargement of another one. So similar shapes have a scale factor. And to find the scale factor, we need to divide two corresponding sides. In the exercise I have in front of me, I have two rectangles that are similar. Because they are similar, they have a scale factor. To find the scale factor, we divide two corresponding sides. So dividing 120 by 30, we can easily find the scale factor. So this is 4, which means that the bigger rectangle is 4 times bigger than the smaller rectangle. This exercise, we want to find the W, the width of the smaller rectangle. Since the two rectangles have a scale factor and the width of the bigger rectangle is 84, I can easily find the width of the smaller rectangle by dividing the 84 by the scale factor 4. And this gives me 21 centimeters. So the width of the smaller rectangle is 21 centimeters. Similar shapes have all corresponding angles equal as well. In this exercise, I have two quadrilaterals that are mathematically similar. And what we need to find here is the LP side. So we need to find the LP. The LP is a side of the bigger quadrilateral. Since we know they are similar, we can easily find the scale factor by dividing two corresponding sides. So the scale factor can be found by dividing the PN by DC. So this is PN divided by the DC. This is 9/6. So this is 9/6, which is 3/2. And to find the LP, the side of the bigger quadrilateral, we need to multiply the side of the smaller quadrilateral, the AD. So the LP is equal to the AD times the scale factor. So the LP is equal to 5 times 3/2. So it is 15/2. This is 7.5 centimeters. We also need to find the side BC. The side BC is a side of the smaller quadrilateral. Because we found the scale factor, we can also find this side by dividing the bigger side, the MN, by the scale factor. In this case, I do division. So I divide 12 by 3/2. So I multiply 12 by 2/3. And this gives me 4 times 2, 8. So 8 centimeters. So the side BC is 8 centimeters. Now we are going to see when two triangles are congruent. Congruent triangles are triangles that are exactly the same. So to check for congruency, we need to see whether any of these three conditions is true. S, S, S means side, side, side. They need to have three corresponding sides the same. Another condition that need to be true is the S, A, S. Either of these conditions. Side, one angle, adjacent angle, and the neighboring side. Or the third condition that they need to satisfy is angle, adjacent side, and angle. So if any of these three conditions is true, the two triangles are congruent. In this exercise, we have two triangles, ADB and the CDB. And we need to check and to show that they are congruent. First of all, we see that the AB is equal to the BC. The lines that cross the sides means they are equal. This is the symbol of equality. So the A and B is equal to the BC. The A and D is also equal to the DC because you see these lines intersecting. So AD is equal to the DC. And another side is the BD. This is a common side. Therefore, the condition S, S, S is true. Three sides, three corresponding sides. Therefore, the two triangles are congruent, are exactly the same. In this triangle, we also need to prove that the ADC and the ADB are congruent. This is an equilateral triangle. Equilateral triangles have all sides equal. So the A and B is equal to the AC is equal to the BC. So by comparing the two triangles ADC and the ADB, we see that the AB is equal to the AC, one side equal. The A and D is a common side. Another side. We can see here that the BD is also equal to the DC because the height of the equilateral triangle is a bisector. It divides the BC into two halves. So then D is a midpoint. Therefore, the BD is also equal to the DC. The AD is a bisector, is a perpendicular bisector. This is true for all equilateral triangles and isosceles triangles. The height is also a perpendicular bisector. So the A in D is equal to, is a perpendicular bisector. So we find three sides equal S, S, S. Therefore, the two triangles are congruent. We can easily prove using another condition as well. For example, the angle A1 is also equal to the A2 because the AD is a bisector of the angle. So comparing the two triangles, the angle A1 is equal to the A2. The side AB is equal to the AC, is a equilateral triangle. And also the AD is a common side. In this case, we proved using the S angle S, side angle side. We can also show that the ASA is also true. Angle, side, angle. For example, the A1 is equal to the A2 because the A and D is a bisector of the angle. Then B is equal to the C angle. And A and D is a common side. So this is also true. Angle, side, angle, and so the two triangles A, B, D and A, C, D are congruent. And today we have covered the topic of similarity and congruency, and we have seen how to check whether they are similar to triangles or if they are congruent. If you like the lesson, don't forget to subscribe to see more lessons like this.